In this video, we're going to talk about the angle of elevation and the angle of depression. In some problems, there are so-called angle of elevation and angle of depression. What do we mean about these terms? And what are their involvements in some problems? So, to understand the angle of elevation is just, let's put it in here, in these two drawings. Imagine if you're standing here at point A and looking up to point B. So this is the angle of elevation when you are looking above the line of sight. So when you're looking at point B and you're in the point A, so this is the angle of elevation. Meanwhile, the angle of depression is just you are here in point A and you're looking down at the point B. So here is the angle of depression. So in elevation, you're just looking up, and the angle of depression is just you're looking down. So we have here example number 1. A tower of 140 feet high stands on the water's edge of the lake. From the top of the tower, the angle of depression of an object on the water's edge on the other side of the lake is 47.8 degrees. What is the distance across the lake? So let us consider the drawing below. So the building is 140 feet tall. So here it is. And they said that the angle of depression on the water's edge on the other side of the lake is 47.8 degrees. So geometrically, the picture here, the drawing is a right triangle, and we can solve it and find the distance across the lake. From the figure above, we can solve for the angle. So to find the angle, let's do 90 degrees minus 47.8 degrees. So the angle is 42.2 degrees. Now we can solve for the x as follows. So this will be tangent theta equals x over 140. So I'm just gonna continue here on this side. So tangent 42.2 is equals to x over 140. Then x is equals to 140 tangent 42.2 degrees. Then 140 multiplied by 0.9067. So x is equal to 126.94 feet. Hence, the distance across the lake is approximately 126.94 feet. I forgot the unit here. So this is the distance across the lake. So here we have example number 2. The angle of elevation of the sun is 53 degrees. What is the length of the shadow of the tree on the ground level, which is 15 feet tall? So if we draw the situation described in the problem, it will look like this in here. So the angle of elevation of the sun, which is 50 degrees, the height of the tree, which is 15 feet, and x here, which represents the length of the shadow of the tree. So we need to find the x. So this is the solution. So in this figure right here, this also describes a right triangle as shown in this figure. So x is the question mark, where x is the length of the shadow on level ground or ground level. So we're just solving for x. X is, so this is tangent 53 degrees. That's too big. Equals 15 over x. And x is 15 divided by 1.3270, which means x is 11.3037 feet. Hence, the length of the shadow of the tree on the level ground is approximately 11.3037 foot.